Our regular viewers will know we're in the process of building this CNC machine, and then we're going to power it with this Best Arc BTC 500 XP. It's a CNC compatible machine. It's got these connectors on the back, but it wasn't really clear what each one was supposed to do. So I made up this little test fixture, and it now does this. So then it was on to CNC machining some of the control panels out, and then fitting out some of the electronics. I've made a start, it's not finished yet, but we've made good progress. And then time for an initial test run. Welcome back to the workshop, and welcome to another video on this CNC plasma build. Okay, quick update since the last video. As you can see, all the panels are now painted and they're back on the machine. We've got the plasma machine in there just to make sure that's going to fit. All the slats are now in, and I've refitted the X, Y and Z gantries. So it's really starting to come together now. I haven't put the lid on just so it gives better access, and also that end panel there that will have all the cooling fans that do the downdraft. I haven't made that yet because it's got some complicated holes to cut out, which hopefully I can use the plasma machine itself to build that end panel. Anyway, before we get to that point, what else have we got on here? Oh yeah, also I've cut out this little rail here to give me good access to the machine. And I think what we need to do next then is get on with the electronics, which sits on an enclosure at the end here. Okay, before we get into that, let's have a closer look at this CNC compatible plasma cutter. Now it's got two GX16 connectors on the rear. It's not entirely clear how you're supposed to wire it up to use that remotely. So before we go any further, let's have a closer look at that. Okay, this is my Best Arc BTC 500 XP. It's a CNC compatible plasma machine, and I'm going to use it with a CNC machine. But before I get to that, I need to figure out how to control it. Now if you go around the back, you'll see there's a 2-pin out there, and they give you a little flying lead for that. That's the arc voltage. Beware, that's direct, so that will be high voltage coming out of there. It's not step down. And then there's a 5-pin GX16 connector at the bottom. Again, they give you a little pigtail for that as well. The confusion that I've found though is that the way they describe each of those 5 pins, it's a little bit confusing on here. It's slightly different in the manual, and I've seen different versions of this unit with different descriptions. I couldn't also find a nice wiring diagram to show exactly what they mean. So we've got this little rig set up here. I've got the 5 cables, so actually there's only 4 of them there. We'll get into that in a minute. A little push button so we can activate one of them. We've got our torch here, and we've got a multimeter as well, so hopefully we can figure out how this thing is supposed to work. And the first one seems pretty straightforward. So pins 1 and 2 for CNC. Now it doesn't have a pin 1, it just has 2 to 5, and actually looks at the end of the connector. I put the multimeter between 1 and 2 and it's already connected. So they've basically shorted across 1 and 2. So as soon as you plug this in, it will go into CNC mode, which I think will then mean the torch is controlled by those inputs, and if it's not plugged in, then the torch will be controlled by the start button on the handle in the normal way. So let's check that out. So we'll switch it on so it'll be a little bit noisy, and then hopefully we'll see a little CNC light come up there when I plug the connector in. So switch on. Okay, looks good. And then I'll plug in the connector, which is over here. Yeah, little CNC lights come on there. So now I think it's in CNC mode. So let's take that out again. And the light goes out, right. Okay, that's in manual mode. The little connector is not connected, so it should fire up on here. Which it does. So if we plug that in, and the CNC lights come on the front. Now, I'm assuming this doesn't work. Oh. Interesting. It still does work. Alright, well we discovered one thing then, so be very careful. Right, so I've got this little push button between 2 and 3, and when I press that it should connect those together, so let's see if that works. Yeah, okay, so just got to remember that both will work. So actually you could use this in manual mode, I guess. Anyway, that's that. So the last two are 4 and 5. They're a bit of a mystery. So on there it says 4 and 5. 4 and 5 pins, output signal arc starting successfully. So what does it mean? That's open circuit now, I guess, and then it just joins them together, or is it going to put a little voltage signal like 24 volts out? I'm guessing, since these are just connections, like logic connections, then let's see, is that open circuit now? So on our multimeter. Okay, now I don't know if it means by arc starting it's actually got the ground clamp in as well and it has to complete the circuit, or whether that pilot's gone, so let's have a look. Alright, it's open circuit now. If I press that, what happens? No. So I'm guessing it has to complete the circuit. Right, we need a different setup. Alright, so this is the setup we got now. So 1 and 2 we know are connected. They're to put it in CNC mode. 2 and 3, I could press this button to fire up the torch, but I'm going to be using the hand torch and I'll use the normal trigger now that we know that both those features work. So what we're going to be checking now, the output of 4 and 5 are going into this multimeter. I've got it on continuity mode. So what I think will happen is, obviously I've got a little test piece here. We're just going to run the torch along here, and once we get that arc established and it's actually cutting, if I keep them both in frame, hopefully we'll see that goes to a value like almost 0. We may hear it beeping, but the plasma is going to make a bit of noise and the fan will be on and so on. So we'll rewind the footage and see if that is, you know, does it basically just join 4 and 5 together once it's happy and it's established the cut. So that's what we're just trying to work out, and then I can make the wiring diagram and the control system suit all those functions. Right, we've got the torch over here, so I think everything's set. We're at pretty low current setting, 2T, plate, and in cut mode. Right. So there we go, let's see if it works. I'm definitely recording, yes. Okay, it's gone to 0. Yeah. Okay, so it pretty much went to 0, so good. Wasn't really focusing on my cut, it's gone over the place, I was watching the screen. Alright, I think we have our answer. Alright, so what have we learnt then? So 1 and 2 have to be connected to put it in CNC mode. I think that essentially is a safety feature that then allows 2 and 3, when they're connected, to fire up the torch via relay or however you're going to run it in the control system from the CNC point of view. So that all makes sense. The only bit I wasn't sure on, but now we've just demonstrated. So pins 4 and 5, they're open circuit. There's probably a relay in here where it just closes some contacts and just shorts those two together. So when it's open circuit, there's no plasma, so you could feed that back to your controller to say I haven't established a cut yet. And then once the plasma's going, it took about half a second, I think, although maybe there's a delay in this, and then those basically joined together and it went basically to 0. So if we fed that signal back to a controller, it would know to hang on and pause until the cut was established, and then it could start going. Okay, I've drawn up a rough schematic of the plasma cutter and then how those controls interface with your CNC control system. Okay, so I've roughly drawn out a plasma cutter here. We've got the air coming in, the 230 volts AC in the UK, and on a 32 amp supply. Just start with the easy stuff. So down here we've got lines 1 and 2 into the GX16 2-pin connector, so that's just reading that voltage, and as you can see it's not divided, so it's going to be very high voltage coming out there, so just be careful. That will go into your torch height controller, and then we've got our plasma cutter and then our workpiece clamp down there. So that's all standard, and I guess on here you'd also have the trigger. Let's just draw it like that. Cool. Now, as we've seen, you can operate that even if this is in CNC mode, so just be careful about that. I guess that's a good thing, because you could grab the torch and then just do a bit of freehand cutting without having to have any configuration or extra switches or something like that. Alright, so that's reading off the voltage, that's the easy bit, and then let's start from the top then. So to actually fire that torch, it needs 2 things, it would seem. So we've got our 5 pins there on our GX16, obviously they are round like that with a little notch. I can't remember where 1 is, but anyway, they're around. Let's look at 1, 2, 3. Oh, I've got 6 there. That's good, isn't it? Okay, there's our 5 pins. I've just drawn them out in a straight line. So it looks like you have to connect 1 and 2, and in the flying lead you get with this, they've just done that internally inside the cable there, so you don't need to do that. So that branches that, and then between 2 and 3, now I had it set up on my demo as just a little push button. So as long as you join 2 and 3 together, so short those out if you like, it will fire up the torch as long as 1 and 2 are connected. In practice though, you'd probably do that with some kind of relay system in the control unit, and when you want the torch to fire, you put 24 volts into a relay. It would bring those contacts together, and those contacts would be joining between 2 and 3. That's probably the easiest way to do that. So assuming 1 and 2 are connected, that will fire up the torch. And then the last bit is, this has got a rough idea about what it might be doing, but in essence, once it's happy that it's established the arc, something, I'm guessing a relay, joins 2 contacts together, and 4 and 5 are joined together with basically no resistance. So probably the easiest way to implement that is in the control system. You have an arc OK that just looks across the terminals on a relay, and when they're open, the arc's not there. If this gets joined up and it's happy with the arc, it'll allow 24 volts to go through this relay, which is part of the control system. This would be the bit you build. Go through there, through those contacts down to ground or 0 volts. Would pull that switch together, and then the arc OK signal go into your controller. Whether it's done exactly like that, I don't know, but that's essentially what it seems to be doing. So I had a look around on the internet and I couldn't find this kind of information for that particular plasma cutter. Maybe it's a bit new, I don't know. The instructions weren't super clear. I don't know why they don't just put a quick diagram on the back of the unit. That would be a lot easier, wouldn't it? Anyway, that is what I think it's doing, and that certainly helps me, and I hope it helps you too. Okay, I thought next we'll do the electrics at this end. So we've got 4 proximity sensors, one here for the breakaway if it hits something, one here for the Z touch off, that's the home for the Z, and then we've got another one that will go in here which will be the limit for the y-axis. So we've got 4 proximity sensors that all come together, and what I thought I'd do is join all the positives and negatives, so the 24 volt supply together, join them here, so then we only got 1 feed for the 24 volts, and then I'll just have the 4 signals that go back, maybe in a single cable. Otherwise there's going to be a lot of wiring coming through here and it may not fit. So to help manage that little interface here, I've made up a little junction box. So my first box didn't turn out that well. It got about halfway through and then it became detached from the bed and it was all whizzing around and turned into spaghetti. So I had another go, and that's this one here, and that was a lot better. But what you tend to find when you've got long deep pieces like this, that just pulls away ever so slightly. I don't know if you can see that. It's pulled up a little bit there, and then obviously that's ruined the finish on the inside as well. Also I had just normal support, so in the same material. This is black PLA, and some of it proved quite difficult to get out. Now I think it was because I had some support PLA in there as well, and originally I thought I'll do that. And then for support PLA you normally have, or the default settings are basically touching the material. And then I changed my mind because that was going to be 3-hour print, and so I put it back to just use the parent material for the support, and I don't think it then readjusted the clearances, so it was really hard to get that off, and as you can see it's made a bit of a mess. So that was number 2, and then number 3 did a couple of things. As you can see some differences. I changed some of the detail, some of the fixing down there which will hold the little terminal block on. And then the other thing I did, then just put these little breakaway features so that it's much more difficult for the fibres to go into tension and pull, because they've basically got a break in them. And this bottom turned out completely flat, and all the finish is really nice now. I think I made some changes to this bit, which is where the wires come in. And the other thing I did is I used, I've got some down here. I went with the 3-hour print in the end, and actually went back to using this white PLA support material. So basically that is the interface between any support material on this, and it comes out really easily. The downside is, because you've got multiple filament changes, it takes about twice as long to print, but you end up with a really nice quality part. Can you believe we now live in an age where you can just draw something on the screen and basically have it in your hand? You'd have to have an injection molding machine, or build it out of parts, or machine it from block of aluminium or something, I don't know. But you can you can have parts like this. Right, next thing we need to do is use the little heat set insert tool there and push these little M2 inserts into there, and then we can mount our electrical block. Now I'm out of M2 versions of those, you know, which have got the lead-in collar. I'm just down to these, which I think are for injection moulding, so they haven't got that lead in, so hopefully we can get it pretty straight. That's not ideal. Let's see if we can get that to go in. Just don't want to overheat it. Okay, I wanted it undersunk because the screws are quite long. Alright, happy with that. Let's clean those up, and then we need to put some little heat set inserts into those. The lid is printing now, so I'll bring that back. We can test fit that. Okay, so we've got our box there, put the inserts in there. I've run out of M3 inserts, so we've got some on order. We'll finish that off, and then we can put the lid on. But for now, we can just make sure it's going to fit. Let's see where the holes are. Also ran out these little M5 button head screws, so these are got like oversized washers on them for metal panels, and I just had to put them in the lathe and turn the flanges down, get them to fit. Okay, time to see if this bit's going to work. So my plan was, I tried lots of different pipes and I had cable chains and all sorts. Obviously this is going to go up and down. Oh, it's connected to the motor, so I can't turn it. And then I just need some way of connecting this back to that box. So my thoughts were, best way to do it, yeah, we'll put the cable in there. Guess we can have it going up, assuming it fits. Yeah. Okay, something like that. And then the other end, I need to go through that box. It's on. Well, I think it needs to be a little bit shorter for a start, but wonder if it's just going to end up breaking the plastic there. Maybe it'll be okay. So that'd be home somewhere. Yeah. Okay, make it a bit shorter, but I think that'll do it. Okay, so it's a little bit congested in there, but I think it'll do the job. In the end, I added an extra one on here because I didn't quite have enough terminals, so I cut that down. It only had 3 on the end, so I've just added this 4 block and then this separate 6 one over here. Okay, I've turned the machine round now, so I've just fed that cable through there. That's for the stepper motor. I'll bring it around here. Quite a lot of cable on here, but I thought it was the easiest way to do it. And we can put our first cable to the cable guide. Okay, so as usual, I've got a wiring diagram, although it's a little bit different to how I normally draw them. So I've been using Easy EDA for some of my projects recently. You might have seen some of those. And I've used that again to draw this schematic. And rather than just drawing the wires that run between each of the connections and it's starting to get a little bit messy, I'm using what they call net labels. So for example, down here, here's all the power supplies. So we've got our main supply comes in, got our ground there. Then we've got a power supply for 24 volts, 5 volts, we've got the 48 volts, 12 volts and the 19 run the power supply for the monitor and the little mini PC. We'll talk about that a bit later. And basically you end up with these little net labels called 24 volts, 0, 5 and 0 and so on. And wherever you see those, that means there's a wire connected between those. So the obvious one is the distribution blocks. So 24 must connect there, and then we've got all 24 coming out going to the different areas. So for example, when you get to the proximity switches, they're in their own little boxes, and you've got 24 volts and 0. You just then know that you need to supply 24 volts to those from distribution block. And then we've got home limits, for example, and they will end up going up to here to the AXBB controller and so on. We've got a big block up here for the AXBB controller. That'll be running off the RJ45, so that's Ethernet, and got all the connections there. Then for the relays, there's 2 relays, safety interlock and the main safety function. Torch height controller, I've gone for the Proma THC. I don't know if we'll get that in this video, but that's what I'm going to use, so that's what I'm heading towards in terms of wiring. And then the stepper drivers, X, Y, Z, and stepper motors. The plasma machine itself as well, because we need to get some connections from there that go back to the torch height controller. And then the basic controls on the front panel. So we've got our start stop, we'll have a latching safety relay as per usual. Have a switch that controls the fans, and then a little feed rate, because I reckon that trying to get the plasma feed rate just right so that it's definitely piercing through but it's not going too slow or too fast. It'd be nice to kind of fine tune that and get used to it, and then once I've noted some of the values for certain materials, I can have a little table that I can create, so that gives me a little bit of an override there. And I think that's it in terms of the overall schematic. Then in terms of how I'm going to physically lay that out, got my little board over here. It'll actually be that way around when I put it together, but annoyingly I've put the dimensions on the other side. But anyway, let's have a look at it this way. So we've got, upside down, where are we? So we've got our stepper drivers here, we've got a load of distribution blocks, relays, that's the Ethernet controller, the AXBBE, and then we've got mains power supply and some little interconnects there, so we can have multiple supplies, because we've got to, from our single power supply coming in, we've got to run the 24 volts, the 5 volts, the 3 power supplies here, and then some of the cabling goes up to the front panel. So we've got some of the buttons shown in section view. There's a cooling fan there as well, and this is what will actually live on the side of the machine. So this is basically what we need to make. I've got most of the bits, not all, but most, and I've got the base frame that it's all going to mount to. So let's bring that over and get started. This is the main board that will go on the back of the machine. These standoffs here, because ultimately I'll have paneling that goes all around the outside, and then there'll be a lid on it as well, but the main components will go onto there. Now, although this looks like a lot of space, when you start laying everything out and working out what's got to join together, I wasn't quite having enough room to fit everything, so I've ended up having to stagger the stepper drivers. So to do that, I've had to make these little brackets, which of course are 3D printed. I've actually marked the holes already, so it should just drop in. There we go. And by staggering them like this on an angle, gives me a bit more room. Yes, I could have put them on their end, but then they end up being really tall, and taller than the unit really allows, because this has got to go back under a certain cabinet, so I can't make it any wider. It also makes the wiring a bit more awkward if you do that. So I'll just get one on there and just show you what that looks like. So I'm just using these drivers, they're very basic ones, but I think they'll do the job. And they go that way, yeah. So you take that screw out. Sit on there, that'll screw in there, and then the conduit runs past there and the wires just drop in. So we've got 3 of those to do. Let's get on with it. Okay, quick update then where we're at. So we've got our stepper drivers in, obviously. We've got all the cable guides in now and the two main DIN rails. Power supplies in for the stepper drivers, for the monitor and for the micro PC as well. These are distribution blocks, so basically you just put a 24 volt feed in here and you got a whole load of outputs as well. I forget how many that comes with each one. So there'll be a 24 volt distribution, 5 volt and the 0, and we'll twin the zeros together for the 24 and 5 volt supply, so we've got a common 0 volts reference. This is going to be the mains power supply distribution center. So we've currently got our little 24 volt supply and 5 volt. Now this is only 1 amp and I'm just a bit worried whether that's going to be good enough, but we'll see how we go because we've got to run quite a lot of that. So that will go. Actually, I won't clip it in because I might need to get to these screws here for the DC output, but let's just give you an idea about how it's going to look. So those will go there, and then I'm getting a bit low on these. These are made by Dinkle. See if I can get the... You probably can't read those. No, these are... I don't know if you can see that. These are Dinkle 2.5N. I like these because they are 4mm. So they're pretty small and you can get lots of them in a small space. You know, for distribution and stuff like this, you don't normally need the real big stuff. You know, they make some big ones like that, for example, and these, you know, they take up a lot more space when you add them all together. I've got some dual stack ones, but I don't like using those for power mains. So I've got a load of these on order because it's the Christmas break at the moment when filming, so it's going to take a few days for those to arrive, but we can drop those on. So we'll have live, neutral and earth, and then this DIN rail will be my star earth to bring all the earths together. So not only the earth for the power supply, these two power supplies as well, but also for the screen around the stepper cable. So I'll put a little screen cable down there. But I won't be putting the 0 volts from the DC on that, because that'll be separate. That can be its own isolated circuit. Right, so I may as well drop these on because I've got them now, and we'll put them on. I guess which way is going to be easier? I think I'll probably do them that way. Probably end up moving these around a bit, but anyway, just to get something in place. Okay, and over here is the AXBBE. That's going to be the control unit. Now I've got the same unit on my router and it's been running for years, hasn't missed a single step, nothing has gone wrong with it at all. So this being a plasma and electrically noisy, I thought let's go with Ethernet again. They're not super cheap, you know, you can get low cost boards, you can get USB boards, you can probably even get parallel port maybe still. But, you know, just to have that lack of worry and just fit and forget, so I'm going for that again. So I haven't ordered that yet. I'm probably about the right place in the build where I need to order that next, but obviously you can see that will go in there. And then in here there'll be a mains cable, and I was going to run it all the way through just to have a strain relief, but I decided I'll go for one of these IEC connectors, put that in the main chassis, and then I can have whatever length I want and I can unplug it and things like that. So that'll go in there. And then the mains, I know it looks like it'll run down this channel, but actually run underneath down here and then go to the distribution block that you just saw me install, and that'll run all the mains powered stuff. The reason for this all the way around is because this needs a lot of inputs and outputs. So our network cable go in there, all the outputs for step and direction, things like that there. We'll have our analog, which will be feed rate override, and there's something else I wanted analog as well. And then our 5 and 24 volts supply will go there. And then we've got the inputs here, which are, yeah, the home and limits from the proximity sensors like this. That's one of the nice things about this particular unit, is that you can run 24 volt sensors directly off it, straight in without having to mess about, so that's quite nice as well. Right, so that's a quick update. Okay, next we'll put the relays in here. So one of them's a safety relay, so this will be this one. It's got 4 terminals on it, one of which will feed back and become the latching relay, so it turns it into an emergency relay, an emergency stop one. Now, I think for home use this style is okay to have that latch, but yeah, for industrial use you'd have to have monitoring contacts and things like that in case something had fused together. yeah, in those kind of situations. But basically I'll be standing next to the machine all the time, and I'm happy to do it with a latching function on here. And then because you've got 4 terminals, you can also where's my, look at the circuit diagram, which will be this one. Because I've got 4 terminals, then once that operates, where's the latch? Oh yeah, okay. So one of the terminals will then become the latch function, so holds it energized. It also means if you go into e-stop, when you come out of e-stop, it won't automatically start the machine again. You have to then re-enable it using the start button that's down here on the control panel. So that's one of them. The other one is an e-stop function that will go to the controller, so the controller knows to stop. That's like a software e-stop. You know, it's not very safe to do that, but because I'm doing it in conjunction with a hardware e-stop as well, I think that is okay. So the controller will stop the motion from that one. There's also an interlock here, so if you're in e-stop mode, this relay cannot operate until you're out of that e-stop mode, and then if you want to fire the torch, it'll energize this, and it only works if this contact is across, you're not in e-stop mode, and then it will allow you to fire the torch. And then the other one is it's going to go to so another layer of safety. I'm going to run the enables from the different drivers through here as well, and so if the stop is activated, it will switch off the drivers. In other systems, I have killed power directly to the drivers, but I'm okay using it like this. I think it'll be fine. You know, the enable should stop it, and I've got the soft e-stop as well, so kind of 2 ways. Okay, so we're over on the CNC machine now. I've just got a spoil board clamped down and the workpiece. There should be enough to get 2 pieces out of here. So initially we're going to make the front part of the control panel. So we've got the cutout of the fan, switches and so on. And I think what I'll do is just peck drill all the holes and then put screws in those, and that'll hold it down a lot more securely than that. And then we can cut the rest of the features out and then go around the profile. And then there should be enough to make the rear panel that's very similar, but only got 1 cutout for the main IEC power connector. So after a bit of clean up, just deburring all the edges and the holes, yeah, it looks like that. So all the controls are going there. That'll be for the fan. We've got our switches in here, little potentiometer, and the little torch light controller going there, and then we've got our fixings allow it to go into the frame. And then this is the frames, our 20mm box, and what I've basically done is 3D printed loads of these. I think it took about half an hour or an hour, I can't remember. Anyway, pretty quick. Just print a whole load of those, and then I've just pressed in a little M5 nut into there, and then they're quite a nice sliding tight fit in there. That means once they're set in position, they won't move around. Okay, that looks good. Alright, let's get some of the switches and see if they're going to fit. Now, because I've got not very much space back here, I've gone for 16mm buttons and things like that, especially things like this. And then I'll just use the little crimp terminals for the back of that. Perfect, yeah. Won't tighten that, we'll just testing everything, and then we'll go into this in a bit more detail probably in a future video, but this is the torch height controller. This one's made by Promo, and you've got the usual connection, so it's going to sample the voltage across the torch, plus or minus. There's a feed out on the back of the plasma unit, especially for that. It is 1-to-1, so it will be the high voltage going there. I don't think we need the center 2. And then we've got there's power, so I'll be putting 24 volts into mine, and then you kind of intercept the step and direction that comes from the controller, so you're kind of intercepting that, and then it goes to the stepper driver, so you can either send pulses out of here to compensate, or you can allow the pulses to come straight through with the normal up down. I believe that's how it works. And then you've got the up down on there, which is well, one of the things you can do is just fine tune the actual voltage that you want it to be at, which essentially relates to the height. And next is the switch for all the fans. Now it's where it goes together, it kind of locates at the bottom and the sides, and then you kind of push something over center and it clicks in at the top. Then to get it out again, you've got to get a little tool down the back here. So I won't push it all the way home because it might be a bit fun to get it out. Alright, so I'm going to clean up the rear panel, get that installed, and then some more sheeting's arrived, which will allow me to do some of the outer panel enclosures. Right, I thought I'd have a look at the panel work that I'm going to use to make up the rest of the enclosure, and it's just arrived, and just pulling it apart. I'm really impressed with the service. Look at that. Yeah, they've got a bit of hardboard in there just to stop the whole thing bending and send it through the post. Yeah, you can't say fairer than that, can you? Okay, so before we can attach the panels, I've just put all these little nut inserts in all the way around, so I'll have something to screw into. And then I wanted the panels to be reasonably accurate because I've got to locate on those holes. Yeah, I'm going to drill them oversized a little bit, but I thought to help me, I'll just come up with a little fixture which is on the drill press. Okay, so the holes have got to be 10mm in from the edge or 20, and so I thought I'd just build this little fixture here because I've got a few of these to do. It only took a few minutes, and essentially what I did is just put this wooden piece on in the vise, put this back piece on here, and then use the DTI here to run across the wood just to get it reasonably square, and then just put this one on at 90 degrees to that, and then just got these clamps obviously to hold it down. So now I can just drop the sheets in, and I did mark it out, you probably can't see that, but scribed it out. And then I've just moved the DTI, picked up off these edges, moved the on the readout there, sorry, on the DROs to 10 and 10, and I can see that it's, you know, it's right over that hole. So process looks okay. I can rely on the DRO to pick up some holes. So let's drill out these panels. Okay, so we've got most of the panels on now. I ended up countersinking the two at the front there and these side ones because that'll allow me to put sheets over the top, you know, so oversized sheets, rather than have to cut them down to go on the machine, so they'll just fit flush on top of there. So you might notice, so we've got all the panels in except there's two around the back, so we'll spin it round and show you what the plan is for those bits. Okay, so I'm going to fill these in with little L shapes and they'll screw into there, and then we've got the drawings there, where to fold it. I did work out the net length. Now I didn't look at the K factor for this. I'm hoping that it's quite thin and there's a bit of tolerance on the holes. We'll just put the bend line actually on that inner dimension there. Okay, so we've got our part in the sheet metal folder here. I don't know if you can see there, but I've scribed that line there, the correct distance. I've got our two holes at this side. But I haven't drilled the other side yet, so we'll fold it, and then just depending on the stretch, we'll see where the other holes need to be, and then drill those. All right, let's get going. Now, I normally use my digital inclinometer here, but the battery's flat. I don't think we've got another one. So I'll just get it pretty close, and then use the square to check it. Doesn't help, the whole machine is at an angle in the vise, so you have to refer to the plate at the back to see where you're at. And it doesn't make reassuring noises either. more. Somewhere there. Okay, I think that's about as far as we can get with all the electronics with the parts I've got. I still need to order the AXBB control unit, and then we can finish off that last part of the build. But let me give you a quick overview of where we've got to, and I think we'll try switching it on and see if some of the circuits that we've made actually work. Okay, in terms of the control panels, you can see I've got everything wired up. That's our start, stop, E-stop, potentiometer for the feed rate. That will control the extractor fans. Got our torch height controller down there. There'll be a little cable guide that will hold this in because this is the high voltage feed, and I want to keep it away from all these control wires. This is obviously running a little conduit as well back here, but before we button it all up completely, I want to make sure it's all going to work. I've got these unplugged for now, just to make sure we're getting the right voltage to those. So I've got all that wired in. We've got our one of the relays wired in, so at least it will click, but we haven't wired up all the contacts. And then that's the torch relay. The distribution block's done. We've got our 24 volts and 5 volts. They're all done. Power supply is done as well. These are just loose at the moment. I've just got to find a way to get those back out, and they'll go up to the mini computer, and the monitor will be on like a kind of control stand in the front of the machine, but we haven't done that yet. And then over here we've got our little connector that will go to the control, the extractor fans. So a reason for doing it like that is so we can put all this on the machine and then plug in the different things like stepper drivers, and stepper motors, sorry, and things like that. Yeah, so we've got our power supply in down there. So we'll just do a few checks to make sure I've got it all connected, and then we'll switch on and see what happens. Okay, so we're in continuity mode, so I'll just put one on the live terminal down there. Obviously it's not plugged in, we're just checking. And then live on our plug is, live on our plug's over here. Okay. And then on the neutral. Yep, and then on the earth. And we should also have earthed all the panels. Oh, missed it. Okay, that's looking good. So coming out of the torch height controller, I've also got this flying lead here, which goes off to the back of the CNC plasma. It just samples the voltage, so I'll just feed that through once we hook it all up, and it'll go into the back of the machine, so that's all fine. Right, let's do one last check, then plug it in and see if we've got voltages. If you can see that down there, yeah, torch height controls come on, which means we're getting 24 volts to that, and we're in E-stop mode, so that's good. Oh, is that the fan come on? Yep, and I've got it connected the right way. It's blowing air out. That's very quiet. If you can hear that. Alright, that's a good start. Let's go looking around and see if we've got the correct voltages. Okay, we're on DC voltage now. Got to be a bit careful because some of it's obviously now live. And let's just check. Let's start here. What we've got going to the stepper motor. Wrong way around. Okay. 36. Okay, I've got that on the low setting for the power supply, so we can turn that up a little bit. Yep. Okay, looking good. 5 volts on this one. Yep. 24 on this one. Okay. And I think that's probably all we can check. All the mains lights are on. Looking good so far. Okay, I've just realised I don't think the e-stop system will work because I haven't got the latch on, but let's see if the light goes out at least. Okay, so I think if we press this, the relay will latch, or not latch, but it will click. And then when I let go, it'll unclick again because I haven't got the latch. Let's see. Success. Right, now we know that works, we'll just try it one more time with these plugged in and hopefully these units will turn on. Obviously I haven't got the drive or the stepper motors connected, but let's make sure they work. Plug it back in. The LEDs around that side, but you can see they are shining on there, so yeah, alright. There's one last thing we might be able to check if we've got power. Going to the monitor and to the little mini PC. Okay, 12 on that, so that's the monitor. 19 on that one, so that's the mini PC. Alright, all checks out so far. Okay, I think that's all we can do for now. Still got to order the control unit and get that wired in, and then get the safety relay wired in, and then wire up all the control terminals that obviously controls. Still got to paint this or protect it in some way, and then I was going to put sheet metal cover over it. Then I wondered about a kind of dark perspex to make it look nice, but it's down near the floor level, it's going to get dusty and kicked, so probably end up doing steel again. And I think, you know, that's going to take a little while, but that's essentially what we've got left to do. Okay, the machine's down here. I'm just using it as a worktop at the moment for the wiring. That stand there will bolt onto the front of the machine, it will come up, and then I can put the monitor and the little computer on there as well to control it all. All the steppers have got all the little green plugs on, and then they've got their earth shields as well, so all that will plug in and go into the main electronic panel at the end once it's actually mounted to the machine. What else is there left to do? Is another sensor to put in there, and basically just then tidy the whole thing up. So quite a bit left to do, but making good progress. Okay, that's it for this video. If you want to follow along with this build series and see how it turns out, feel free to subscribe. If you've got any comments, feel free to leave those down below as well, as usual. And with that being said, thank you very much for watching, and see you next time.